So this is an unplanned follow-up video to our the first video in this new series, which is basically what is IIoT, what is MQTT, and we're starting by explaining the automation stack. So one of the things that occurred to me, Matt Wapota made a comment that actually made me think, you know, we actually should do two versions of every video. So the idea of this session, this series of videos, is our audience are people who just don't understand what IIoT is. One of the things that we've learned through the course of our experience is that the decision makers are not technical in any way, shape, or form, and they're generally not up to speed on what the value of IIoT is. So we spend a lot of time trying to explain the value. They know they need to do something with Industry 4.0 and Digital Factory, and there's a later video that kind of goes over that. In fact, I'll show you the rest of the videos in the series. So I did get a chance to review them last night. This is the automation stack video. There's a new video. There's a video called A New Way of Thinking, which essentially explains the difference between the personal digital transformation and the industrial digital transformation, and why is it we're further along in the personal digital transformation than we are in industry. We explain what IIoT protocols are. We explain what is IIoT, what is the digital factory, what is MQTT, and why does it matter. All of these videos are structured, and this whole series is designed to for an audience that does not know what we do. So most of the people who subscribe to our channel and most of the people who interact with us on LinkedIn, they speak our language. But not a lot of the decision makers do. So that's the first thing. The video series is for a very basic audience. Okay. But what it got me thinking that we should do a more advanced version of each video. So I'm actually going to do that here. So this is for the people who do speak our language. Matt Wapota brought up a really good comment. He said, you know, great commentary. My view is almost exactly the same. He said I would shift the whole pyramid down one layer and include the equipment and I/O as the bottom layer of the pyramid. See attached image. In my opinion, the cloud is sort of tangential. ERP and MES Scada apps are moving from on-premise to the cloud. I don't know if I agree with that. Definitely agree on the ERP side, definitely not on MES and Scada. I agree that IIoT is drastically changing the stack, and I have noticed three major trends. Number one, data and applications are moving to the cloud. Definitely. Not all applications, all data. Scada, MES, and ERP systems are converging. Yes. In fact, this is what organizations have wanted to do forever. The difference is they've oftentimes been completely different platforms. And so the only way for the three of these to converge would be like through a software API, which means you have to have an expert in those software APIs. And there would be an API between each layer. So between Scada and MES, there's an API, and between MES and ERP, there's an API. That's fundamentally changed. Inductive automation is the one that really changed the game there. PLCs and I/O are bypassing the traditional stack and sending data directly to other apps. I totally agree. MQTT is one of the most popular ways to achieve this. For example, AWS Greengrass. It's not that they're bypassing the traditional stack. It's that they have an additional connection. So they have a connection that is in addition to its connection to the traditional stack. So what that means is that getting data somewhere is not dependent upon going up through the stack, which is exactly the point of what our video was yesterday. Is that the idea is that organizations spend a ton of money trying to get their data to where it needs to go, and essentially they're doing it through multiple connections up through a stack. There's no point in doing that. Move to a star formation. Have all of the nodes in your environment published to a namespace that then all of your applications and consumers connect to and grab their data. And I'm going to show you how that works in a second. So I did comment, and so I do love the definition. It's right in line with what we're saying. Matt definitely knows what he's talking about. The remaining videos in the series have been edited. I had a chance to see them. I just showed you guys that, and I think you guys will enjoy what we have today. But there's two points I do want to expound on. Number one, we're making this series as simple as possible so anyone inside or outside of the industry can understand what we're saying. In my experience, the only people who understand Matt's chart, and I'm going to show it in a second, are people who understand software stacks and integration. And that's part of the problem. Part of the problem is the reason we haven't moved, the reason that industry's digital transformation is lagging way behind our personal transformation, the consumer digital transformation, is because decision makers don't understand it, because we've been presenting it wrong. We've been presenting it in a way that they can't consume, and they're not going to tell you that. We're being vague with the term cloud for a reason. We are. It connotes over the internet or off premises. So when you say cloud, the first thing people think is you're sending your data off premises, and that's just not the case. But we have to overcome that misconception. Scada, MES, and ERP are never going to exist over the internet or off premises as long as decision makers have concerns about security and those layers contain intellectual property. We have to do two things here. Number one, we have to redefine the term cloud, and we have to illustrate the value of exposing data. All right, so with that being said, I'm going to do this advanced explanation of the automation stack. Matt and I are in total agreement. In fact, we have a PowerPoint presentation that shows exactly what he's talking about. What we decided to do was combine PLC and HMI for the purpose of this video series, because decision makers do know what PLCs are and they do know what HMI is. We left all of the instrumentation and other edge devices out. We're not using the term edge in our videos yet. In fact, I don't think I even mention it in any of the videos that have been produced so far for this series, because then we have to define what edge is, and that takes decision makers' eyes off of what we're trying to explain to them, which is value. Okay, so totally agree with Matt. I'm going to go through the stack in much more advanced terms, and we're going to start on the edge. So we actually call this the plant floor in level 0. So you'll notice the presentation yesterday, or in the video, and I'll include the link in the link of this YouTube video and the LinkedIn post. We only had 5 layers. We combined PLC and HMI. But when we're talking about it in an advanced level, when we're talking about it in an advanced way, then what we're doing is we actually have an edge layer, and then you have an HMI layer on top of that. Then you have a Scada layer, an MES layer, an ERP layer, and a cloud layer. I'm going to explain what all these things, examples of them. So the PLC edge layer, that is your instrumentation. It's all the stuff that's on your plant floor. It's at your well site. It's at your wastewater treatment facility. Everything that's actually on premises, that is your edge layer. That's all your instruments. It's your routers. It's your switches. It's your PLCs. It's the brains. It's the thing that does your process. The process control component is always a combination of instrumentation, pressure switches and flow meters and that kind of stuff, and something to run a program that then triggers those, takes information from those instruments and makes decisions about how to run the process automatically. Right? That's a logic controller, right? So that stuff's all on the edge. The reason it's on the edge is because in many applications it has to operate, cycle the power. It's always going to run. You can disconnect it from the network. It's always going to run, and it has to run fast. Okay, so as we move up the stack, we're moving across the wide area network away from the local area network. And in most cases, the plant floor doesn't even have a local area network. Oftentimes, you may have like Profibus PA from your instruments to your PLCs, right? Or Profibus DP, or this is the process automation layer, and it's always on premises, and it includes all the instrumentation. So in an IIoT architecture, we're not just connected to the PLC. We're connected to all of the smart devices. We're connected to our router. We're connected to our switches, and we can pull information from that stuff. Okay, the HMI layer is always on premises because the operator, you still have to have some type of direct control on your machine, on your line, on your well, that kind of thing. The examples of this would be like Redline, WinCC, PanelView Plus, Maple Systems, Ignition Edge, that kind of stuff. Those are your HMIs. Okay. Your Scada layer is always on premises right now. I mean, you have some cloud-based Scada systems, but organizations move away from cloud-based Scada systems, not toward them. And the reason why is because most of the time it's only in the cloud because they're purchasing a hosted service. They don't have their own on-prem Scada system, and they've got to pay a consultant to add and take devices away and that kind of stuff. It's generally on premises. It's not always, but generally. Examples would be Ignition, Wonderware, Factory Studio, Factory Talk View, Siemens WinCC, all that stuff. The reason we don't use Rockwell solutions on here, I'm going to talk about Rockwell in a minute, or Siemens solutions on here, is because they're not IIoT compliant, although Siemens is moving in that direction, and Rockwell might be with the partnership with PTC. I'm not quite sure yet. The MES layer is on-premises or off-premises, mostly on-premises. Examples of this would be like Hydra, MPDV solution. Hydra is an MES system that natively integrates with SAP. It's a very popular solution. There's lots of these. Traxxas, I mean, there are thousands of examples of MES solutions. What the MES system does, and I explained yesterday, I didn't really explain the MES system in an advanced way. What an MES system does is it takes the work order that is produced by the ERP system to produce widgets, and it executes that work order most of the time with an operator in the middle. So that is, I'm gonna do a bunch of stuff on my line. I'm gonna produce my widgets. The MES system is the invocation of the work order production run, and it is the collection of data during that production run, and then it is also the reporting of that information to other places in the enterprise, most of the time back to the ERP system. The reason this matters is because it contains production and costing information, right? In the end, it's all about money. It's all about profitability. It's all about generating revenue. The MES system is the connection between the business decision makers and your plant floor. Scada, HMI, and PLC, the Edge, this is just for you to be able to do your job. This is just so operators can run the environment. That is, make the machine go, right? The Scada is so the supervisors can know which machines are going, right? Or the control room to notify distributed people of alarms. The MES system is the most important system in your entire organization. More important than ERP, and it's more important than Scada, HMI, and PLC Edge. MES is the execution of your business. That's why it's tied to the business unit. The ERP system, again, it's on-prem, off-prem. It's almost always on-premises. This contains like all of your intellectual property. This is how much you're paying for your raw materials. This is how much you bought your equipment for. This is how much you're paying your people. This is how much it costs me to run my machine every hour. That's what the ERP system is. It has all of that information in it. It also has all of your product codes. So all of the products I produce, they live inside my ERP system. All of the routings, that is, when I'm going to produce a finished good of Z, it's going to go through these 12 steps. I have these 12 operations it's going to need to go through, and each operation has its own bill of materials. It has its own raw materials. It has its own vendors. It has its own recipe set points, as all those things. The ERP system contains all of that, okay? At the end of the day, companies want to know how much money they make for every widget they produce, and all of that's calculated in the ERP system. For most companies, though, it's an estimate. It's not real cost. Real cost is dependent upon. So, for example, my machine does not cost me the same amount when I'm running it as it does when I'm not running it. Okay, so when my machine is running 9 hours a day, it is only consuming 9 hours of high load electricity. It is only consuming 9 hours of high load water flow, right? The ERP system, because the ERP system doesn't know when the machine's running or not running because it's not connected to the edge most of the time, the ERP system has to estimate what are the average number of hours this actually runs. That's why you'll see in ERP systems, they will say, if I'm going to do a changeover, my standard changeover is 1 hour. The reason they care about the changeover is because they want to know how much does the machine cost. Changeover is, you're not producing anything on changeover and you're paying labor, oftentimes high labor, for your technician to get your machine set up, especially like in CNC environments and that kind of stuff. ERP contains all your business information. It is the most important piece of software for accountants and for executives. But the MES system for the business unit is the most important system. And by the way, most of this is paper. Most of it is Excel spreadsheets. Most of it's boards, whiteboards, or a chalkboard. And we're going to do this and do that. And I make decisions about executing my business based on how we did yesterday, not on how we're doing at this very moment right now. And then cloud can be on-premises or off-premises. One of the things I said to Matt in my comment was that when we say cloud, everyone thinks it connotes that it's off-premises. But I mean, you can run your own AWS servers, Azure, Kafka, Hadoop. There's a billion of cloud-based solutions out there. You can run them locally on premises within your network, or you can purchase the servers from AWS, and they're in an Amazon data center, but all the hardware is yours, and they're connected to you, to your business network over like an MPLS or a VPN, right? So this is AWS Azure. This is Greengrass running Lambda functions. These are data lakes. This is where I'm just taking all my information, all my data from the edge or from my MES system, Scada system, ERP system, and I'm just dumping it in a data lake. I'm just storing it all in the same place. And then what I do is I write algorithms, machine learning algorithms that say, here, all my information's over there. Go spit out relationships for me. Just look at the data. But we have a product called Sieve, which we open sourced it. It's a product we did for a wastewater group, which basically can look at database log tables and spit out information about events that are in those logs. We don't have to tell our software what the information in that database is. And these machine learning algorithms will spit out information just by being able to consume all the data. And it's information humans can't derive. Okay, oftentimes it's too nuanced. But it's information that can help us save money and become more efficient. So this would be things like machine learning. What is an example of machine learning? My bearing lasts 800 strokes when I run this product. It lasts 12,000 strokes when I run that one. So if I'm running that product A 60% of the time or product B 40% of the time, then how long is my bearing going to last? That's what a machine learning program will do for you. Predictive analytics is determining issues that might come up. In the old days, it was just when might things break, but it's not so much that now. It would be predictive analytics would also include things like, hey, we're getting really close to Christmas break. And based on the data we've collected over the last 3 years, our OEE drops from 84%, that's our efficiency in our plant, from 84% to 70% between in that week leading up to Christmas. For whatever reason, people are distracted, too many people take days off, whatever it is. The predictive analytics would spit out information, say, hey, your schedule's inaccurate here. You're operating on information based on how you run when there's no holiday coming up. Okay, this is an example, but you get the idea. So this is a more advanced look at the automation stack and how it all plays together. Now, what I want to do is tie this advanced look into what it is we're ultimately trying to explain to people, which is we need to be using IIoT protocols and MQTT. So what I'm going to do is show you an example of a namespace. So each of these layers contains information. I'm just going to use the PLC Edge example. The PLC Edge, the Edge layer, the instrumentation layer, the plant layer, has lots of smart devices. I could be using Anderson-Hauser pressure transmitters and flow meters. I could be using Opto22 PLCs. So my Opto22 PLC wouldn't just tell me information about the program I'm running, the tags I created, but it would tell me a lot of information about how that PLC is running. And over OPC UA, you can consume some of this system information, but not a lot of it. There's a lot of really good information on these devices that the OEMs use to diagnose how those devices are operating. Well, we can take that information and put it in a namespace if we use IIoT protocols. So this is an example of a namespace, okay? So what that means is that each layer of our automation stack publishes into a place in the namespace. And so people have a choice to consume data from the Scada system, or they could consume data from the Scada layer in the namespace. Okay, so I have this namespace, which, number one, this is our plant, or our enterprise. So this is our ERP layer, right? This is our node information about that layer. Okay, so I could have something like a server running at the enterprise level that contains like Active Directory. It's my domain controller for IntelliC integration. Well, I could, if I use an IIoT protocol with that server, right? For example, MQTT or DMP3, right? Or SNMP, any of those types of protocols, I can publish the information about that node into this namespace. Okay. So the second layer is Dallas. So Dallas is going to be our plant. We have Intellic has a plant called Dallas. I have information about that node in my namespace, and then I have information about that node, and then I have all the areas in my plant. My first area is plating. In this case, will be gold plating area. So all of my plating lines will live inside of this part of our namespace. If you use SAP, you would actually have an ID for this. So I could have an ID number of 900 here, and I could have an ID number of 901 here, and I could have an SAP ID number of 902 here, and then my work center number would be, say, 903 here. Okay, so your ERP system organizes your information this way. Okay, so these are directories, but I've got my plating line. I have information about that plating line node. I have information about each of the layers: cloud, ERP, MES, Scada, Hmi, Edge. We're going to talk about the Edge side. So in our namespace, I would just have this thing called Edge. It's our Edge layer, and that Edge layer is going to contain all the devices. And so the first device would be the PLC. That PLC, we have information about that node, the health of that PLC. We could have in-feed count come from that PLC, out-feed count, waste count come from that PLC. Also, any of the calculated values that the PLC produces. But what we wouldn't get, or what we wouldn't want to do, is get our instrumentation values from that device, because we can get them from the instruments directly for our namespace. Our PLC is connected to those devices, let's say over Profibus PA, because that's a super fast protocol. Maybe my PLC needs to get that data at less than 100 milliseconds per cycle, say 8 milliseconds per cycle. You can do that over Profibus PA, right? So the connection between the PLC and the instrumentation on the plant floor, it may be a non-IIoT protocol because for high-speed reasons. But in our namespace, the instrument not only connects to our PLC, it also connects to our namespace, which all of our software would consume from, and all of our decision makers would get their information from. So device 2 is an instrument, would have node information, and it would be pressure transmitter 1, and then it would contain everything. This device 2 could contain things like scaling information, health of the instrument, how long it's been running, all that kind of stuff, and obviously the values, right? We could do configuration by writing a value back into this namespace that then sets our instrument up. Device 3 is an instrument, pressure transmitter 2. Device 4 is an instrument, flow transmitter 1. Device 5 is a network device. It's actually a router. So this is the idea of the namespace, the unified namespace for the organization, okay? This is the holy grail. We do this all the time, and in fact, I was going to show you an example of a namespace we've created for another customer, but I haven't done that. So I want to talk about one more thing on this advanced element, and that is the importance of open architecture in doing this solution. In a later video, what you're going to see is some of the reasons or some of the realities. That is, why is it that every single plant knows Industry 4.0 matters, digital transformation matters, the digital factory matters, but they're not doing it. And we said in the original video, the reason why is they just don't know how. And they've been bringing tons of partners in. We see this all the time. I mean, I can tell you that at Intellic, 90% of our business is us coming behind someone else and doing something they couldn't do or fixing something they tried. That is a huge part of our business. Our reputation is we're good at all these layers of the stack. But we share this information with other integrators all the time. I mean, I can't tell you how much time I spend answering questions about Ignition, Factory Studio, MQTT, etc. The reason that this isn't ubiquitous in the market yet is because the decision makers don't know how to do it, and that's what this whole video They don't know how to achieve their goal, and that's what this video is all about. It's to kind of explain to people, A, what is the value, and then how to accomplish it. So I'm gonna use Rockwell Automation as an example. I'm a huge fan of Rockwell's PLCs, which are really Allen Bradley PLCs. But I'm a huge fan of Rockwell's PLCs. I am not a fan of Rockwell's business practices. The reason why is because, in my experience, because they're a publicly held company, they put their best interest first, always. And it doesn't matter who you talk to. I could put a bunch of integrators in the same room and bring this up, and everyone's they're gonna know exactly what I'm talking about. They all say the exact same things. Rockwell is not a popular company when it comes to their business practices. The reason that they did their partnership with PTC is because PTC had Rockwell identified last year that they were way behind the ball when it came to IIoT. They were 10 years behind. And there's a video that we have from Automation Fair. I mean, they were easily 10 years behind all the competition. And this move with PTC was to help catch up. They spent $1 billion because they needed to catch up fast. And that's what happened here. PTC did the acquisition with Kepware because Kepware had all the protocols and had all of the edge connections. PTC and ThingWorks, they had this layer. Not really Scada, but think MES, ERP, dashboarding, that kind of stuff. Think cloud also. So PTC had this layer, Kepware had this layer, and what PTC is trying to do with ThingWorks is basically sit their ThingWorks platform on top of what Kepware did with connectivity. At the same time, both Kepware and PTC were working on IIoT. That is, moving away from this data being handed up through the stack and moving to a more of a star architecture. So I'm going to go back to Matt's comment in the LinkedIn video. That is, he said, data doesn't need to be handed up through the stack. Correct, it doesn't, but it still happens. So you're going to have scenarios where the PLC is connected directly to the HMI, but the PLC is also concurrently publishing into a namespace that Scada and MES would connect to. You may have scenarios where PLC, HMI, and Scada are all connected directly, but the PLC is still, and the edge devices are still publishing into a namespace, and the MES system is getting its information from the namespace. The point is, we're digitizing and unifying seamlessly the stack. Okay, so the manual part of the stack may still exist, except there won't be any people manually transmitting that data. We don't want to do that. We want those people to spend their time analyzing data, turning actionable information into efficiency. That's what they're supposed to be doing. So the partnership between Rockwell and PTC was to catch Rockwell up. Okay, so one of the reasons you notice I don't make any videos about Rockwell, and it's not because I don't like their products. I do. It's just their philosophy is different. They believed in the unified architecture. They even use the term connected enterprise. Well, the connected enterprise is Industry 4.0, but they just don't want to use the term Industry 4.0. They want to coin their own term. And the problem is Rockwell does not advocate for open protocols. They want to own the whole stack. Well, the problem is they don't make the best product at every stack. They make the best product in terms of PLCs. And if you want to do like motion control, then we can argue that Mitsubishi makes the best motion control product. You can argue that Siemens makes the best integrated product. If you want to do process control and HMI all together, I think TIA Portal is a superior product to what Rockwell or what Mitsu or what Omron or what any other manufacturer provides. So when I'm choosing my PLCs, I am doing it two ways. First thing I'm doing is I'm saying, what is the best hardware for the control theory? Okay, that's the engineer in me. And then the second question I ask is, is it open? And if the answer is it's not open, I don't use it, because process control is not the most important part of your business. Okay, that's not where you're going to capture your efficiency. You're not capturing your efficiency on the process control layer. You're capturing your efficiency here. And you need open architecture to do that. You need to be able to pick the best platform at each layer to do that. You can't be compelled to use Rockwell PLCs, Factory Talk Panel View Plus, Factory Talk View, whatever Rockwell's calling their MES solution now. They keep changing it. And now and they don't provide an ERP system. So then they have a partner, right? They've got their unified partners and all that stuff. The reason we don't do that is because Rockwell's partners don't always make the best solution for the application. What we recommend to our customers is the best solution. In some cases in the cloud, it's going to be AWS. In some cases, it'll be Azure. In some cases, it's going to be Kafka. In some cases, it's going to be Hadoop. In some cases, it'll be something else. When we evaluate a solution for a customer, we are telling them what is best at each layer. We are not saying, just because I'm using a Rockwell PLC, it means I'm going to use all Rockwell stuff going up. And I don't mean to pick on Rockwell. There are a lot of other companies like this. It's just everyone can relate to what I'm saying about the Rockwell stuff. This is the importance of the automation stack. And in fact, or the new automation stack. And in fact, Inductive Automation posted a video, a link from Automation World yesterday on their LinkedIn page. You go to look at it, about how if you're a provider of industrial solutions, whether that's hardware or software, and you're not going the open source route or going the open architecture route, you're going to be out of business. And I've been saying it for years. I can tell you right now, if you're not going that route, you will not be in business. If you're an integrator watching this, okay. So let's start with OEMs. If you're an OEM who works in the Hmi PLC Edge Layer, and you're watching this video and you are not currently looking at your equipment and saying, how can I connect my equipment using MQTT or DMP3 to an ecosystem, then people aren't going to buy your equipment, because our customers are requesting open architecture. They are requesting this data. If you are a Scada platform and you don't play nice with open architecture or open source software, you're not going to be in business. If you're an MES solutions provider and you don't play well with open source, that's MQTT or DMP3, or actually DMP3 is not open source. You have to have access to the specification to see what's under the hood. But if you're not playing nice or have an open architecture philosophy, you wrote a custom API and that's the only way you can talk to your software, you're screwed. I mean, you're not going to be in business. Same thing with ERP and cloud solutions. I mean, now you can watch this video and think I'm a know-it-all and I'm a jerk, but I can tell you that's not going to change the eventuality of your business if you don't focus on open architecture and IIoT. All right, so that's the advanced version of the stack. I didn't do a script or anything, and there's no fancy editing in here, so I'm sure it's going to be a lot more boring to watch than what Zach produced. But anyway, it's meant to be more in detail, and I'll probably do this for all the other videos as well once we launch them on LinkedIn. Maybe the next day I'll publish this. But anyway, thanks for watching, and if you got any questions, comment below. Bye-bye.